Okay, now that we have the feasible region, let us bring in the objective function and see how much we can increase the ISO profit line. Okay. Of course, we can throw the redundant constraint out. Okay. Throw that out. So now bring in the ISO profit line. Okay. So remember, we did the ISO profit line first. So now try to increase the profit. At the same time, do not leave the feasible region. Right now, all the points in this line that are feasible will give you the same profit that's represented by this ISO profit line. Okay. Now, keep increasing, and then you see that at this is the point where you get the maximum value for the ISO profit line, and you still have a feasible point left. Okay. If you increase the profit anymore, then none of the points on the ISO profit line will be feasible for the problem. Okay. So now we know that that is our optimum solution. Okay. And that is an intersection between the green and the purple line. Okay. Intersection between x2 equal to 1200 and 5x sub 1 plus 6x sub 2 equal to 10,000. So now we know the x sub 2 value. To find x sub 1, so since it's an intersection, we can plug in the 1200 into x sub 2 and then solve for x sub 1. So x sub 1 will be 10,000 minus 6 times 1200 divided by 5. So that will give you 560. Okay, so x sub 1 equal to 560, x sub 2 equal to 1200 is represented. This point represents this point. That's our maximum profit solution, also called optimum solution. Now we can find the value for z. Z, remember, is the notation that we use for the objective function. That's the profit. Okay, 80 x sub 1 plus 129 x sub 2 gives you the profit. So this is the maximum profit that we can feasibly make. Okay, so this is called the graphical solution. And a couple of things about this graphical solution. Okay, the feasible region will always be a region of straight lines, or region contained by straight lines like this. You will never have curved lines. That's the reason why this is called linear programming. All the equations are linear. So you will have straight lines. The edges will all be straight lines of the feasible region, and the optimum solution can never occur inside the feasible region. It has to be one of the corner points, because if it is internal to the feasible region, you can always increase the profit, or if it is cost line, you can always decrease the cost line until you get to some corner point somewhere. Only at a corner point you will face a situation where you cannot increase the profit or decrease the cost anymore without leaving the feasible region entirely. So that means that we can also compute the coordinates of all the corner points and evaluate the z value, the profit function, for the corner points only, and then select the one that maximizes profit. So instead of drawing the ISO profit line, so the advantage of ISO profit line is that you zero in on the optimum solution and you have only one point, intersecting point, whose coordinates we have to determine. But if you take the corner point approach, you don't have to draw the ISO profit line, but you have to find the coordinates of all the corner points. So here, let's call these corner points A, B, C, and D. Okay, we can omit this because this is a profit problem. 0, 0, even though it is a corner point, that's not going to be the profit maximizing point. So we'll find A. A is x sub 1 is 0, x sub 2 is 1200. Now B is an intersection of these two lines, and we just solved the coordinates for point B in the previous slide. So that was 560 and 1200. The next is C. So C is x sub 1 equal to 1000, and that's one line, and 5x sub 1 plus 6x sub 2 equal to 10,000 is an intersection of these two. So if you plug in for x sub 1 1000 and then solve for x sub 2, you get 833.33. So that is the third point. Okay, and the fourth point is x sub 1 is 1000, x sub 2 is 0. Now compute the value of Z, that is the profit. Okay, remember the profit is 80 x sub 1 plus 129 x sub 2. Compute the profit and select the one that has maximum net profit, and that, as we saw previously, is corner point B, which represents produce 560 units of basic model, 1200 units of XP model. That will give you the optimum maximum profit of 199,600 units. You'll still stay within the constraints of assembly hours, testing hours, and the sales of 1,000 and 1,200 for the two products.